Okay, imagine you had a lens and you pointed at some object. In this example, I'm going to treat this person here as an object. I'm going to try to find out where the image of this person is going to be formed from the lens. So I'm going to use a ray diagram to that. Maybe the image formed is going to be magnified and upright, or maybe it's going to be inverted upside down and diminished, meaning smaller, or maybe it's actually a virtual image that's formed on the left hand side like this. So it doesn't matter what the object is, we're going to represent it using an arrow like this, and we're going to use a ray diagram to figure out what kind of image is formed. Other features of this diagram you know about is the principal axis, that's just there for reference. Then you've got the focal points or the principal focus, and that's on either side because it doesn't matter which way the light is coming from, it's going to focus it through the focal point. And then we've also got the focal length there as well. This lens here, you can see it's a convex lens or converging lens. It's going to bring the light rays together. But I'm going to represent it using a symbol like this. Okay, let's get started. So I'm going to give you a checklist here of things you need to do to get the image and also to be able to describe the image. First step, draw a ray that goes through the center of the lens. So it's going to come from the top of the object and it's going to go right through the center of the lens like this without being deflected. And it doesn't even matter what type of lens I use, any light ray that goes through the center of the lens doesn't get deflected. Next step, draw a ray that's parallel to the axis and then goes through the focal point. So draw a ray that's parallel to the axis like this from the top of the object, and then it's going to go through the focal point like this. Okay, and then extend that line quite far. Okay, see where the lines meet? That's where the image is going to be formed. So the image is formed here. I'm going to add an arrow there to show that it's actually upside down. Okay, that's the image there. Okay, the next step is I also need to add some arrows because I need to show the direction in which the light rays are going. So add arrows going towards the right like this. Okay, now it's time to describe the image, the final step. Okay, first question is it upright or inverted? And as you can see, the image is actually upside down. That's why I drew the arrow. So it's inverted. Next, is the image real or virtual? So because the light rays are actually meeting and is on the right hand side as well, because they're meeting is a real image. So we're going to say it's a real image. I will come back to virtual images later. Is it magnified or diminished? As you can see, actually the image looks a bit smaller. So that basically means it's diminished, it's smaller. And then finally, the last thing you need to say is by what factor it's been diminished by. So to do that, you use the equation magnification equals size of image over size of object. Now to find this, I'm going to actually count the size of the object first. So I'm going to start off by counting these squares, count them one by one. If I count this, I'm getting 10 squares for the object, the height of the object. Now do that with the image as well. So I count this. The image is 7 squares. So the image size, which is 7, divided by the object size, which is 10. So the magnification is times 0.7, which makes sense. It's smaller than 1 because it's actually diminished, it's smaller. Okay, that's it. That's all you do to describe it and get all the marks here. Second example, we're going to do the exact same thing, but now the object is at a different distance. Let's look at our checklist here. First thing, draw the light ray through the center of the lens undeflected, like this, from the top of the object through the center undeflected. Second step, draw a ray that goes parallel to the axis like so, and then it goes through the focal point. Great. And you can see it's meeting. These light rays are actually meeting. So that's where the image is going to be formed. Okay, that's our image there, and I've drawn an arrow there as well. Okay, the next step is to draw arrows to all the light rays as well. So let's not forget that. So add all these. This is easy to forget and to draw these arrows there. Okay, now our checklist of describing the image. So is it upright or inverted? As you can see, the image is upside down, so we say it's inverted. The light rays are actually meeting together, so that means it's a real image that's being formed on the right hand side. And then is it magnified or diminished? The image is bigger than the object, so we say it's magnified. And finally, we need to give the factor. So again, using our equation, image size over object size, let's count the squares and figure out the size of each one. So the object we know is that hasn't changed, it's actually 10 squares. The image, let's count that. So it's going to be quite a few size blocks here. So that's going to be 15 squares. So that's going to be the image size, which is 15 first, divided by 10. So times 1.5 bigger, which means that it's a bigger image, is magnified. The third example, now the object is very close to the actual lens itself. It's actually going to be quite different this time, but we still follow the same checklist. First thing, the light ray through the center of the lens from the top of the object. Second one, parallel to the axes, and then through the focal point. Okay, so maybe you notice now there's an issue because these light rays are not meeting. Okay, so what's going to happen is, imagine you're standing on the right hand side where you're expecting light rays to meet. They're not meeting. What your eye is going to do is going to trace these light rays backwards. Okay, so we're going to trace them backwards. I'm going to get rid of this part here to make some space. I'm going to get a ruler and I'm going to trace this light ray backwards. Okay, and I'm going to do the exact same thing with the other one. Draw it so I'm lining it up with the light ray and then keeping it going the same direction but backwards, using a dotted line because these aren't actual light rays. It's just where your eye thinks those light rays are coming from. Okay, so that means where those light rays appear to meet is where the image is formed. Okay, and then draw an arrow like this. Okay, so this image, let's start describing this image. Oh, I forgot to add all the arrows, so let's add all the arrows. You don't need an arrow for the dotted lines. Those are just construction lines. Okay, is it upright or inverted? Well, you can see it's pointing upwards. Now it's actually upright, so that's correct. Okay, and then is it real or virtual? Well, this one is a virtual image because the light rays aren't actually meeting. It's just your eyes tracing the light rays back and forming it where it appears to meet, where the light rays appear to meet. So it's a virtual image. And also, it's on the left-hand side, it's on the same side as the object. Is it magnified or diminished? As you can see, the image is bigger, so we say it's magnified. And finally, we'd give the factor. So let's start counting the squares for the image and the object. The object is still 10. The image, if I count the squares slowly, it's going to be quite big. So it's around 8.5 squares. So 8.5 divided by 10 is times 1.85 times bigger. Example 4, we need to identify 3 errors in this student's ray diagram and description of the image formed. Okay, so these are common mistakes that I see students making. We're going to just look at this diagram. It looks correct, but there's lots of things wrong with it. First thing is actually the light ray that's supposed to go through the center of the lens. So let's look at our checklist again. It's not going through the center of the lens. It's going through the focal point. So that one is wrong. Okay, so we need to go like this through the center of the lens. Okay, but let's just pretend they got it right. And let's see what other mistakes the student has done. So it should be going undeflected through the center of the lens. Second one that's wrong is that second light ray there is just going through some random point. This is the one that needs to be going through the focal point on the right hand side. So instead, this is the one that should be following this path. So the image formed is completely in the wrong place, but let's just pretend they got it right. Let's look at other errors they've made. Other errors they've made here is, they've got to add arrows to the image. You need to show which way the image is upright, inverted, so that needs an arrow. So you need to add arrow to the whole diagram to show which way the light rays are going. The final mistake they've made is it's inverted, it's real, and it's diminished. That's fine, but the magnification is times 2. That's wrong, because if it's diminished, it should be smaller. What they've done here is they've divided object size by image size when they should be doing image size divided by object size. So it's the wrong way around. It should be 5 divided by 10. A final example here, we're going to look at other common errors that I see students making. First of all, in this image here, it looks correct, but one of the biggest mistakes they've made is actually it's not even a converging lens. This is the symbol for a diverging lens. A converging lens looks like this. Okay, so here, this diverging lens shouldn't even be focusing lights together. It should be diverging it away from the focal point. Let's assume the student is correct and look at other mistakes the student has made. They haven't drawn the rays correctly, the virtual rays. It should be aligned to the actual real rays. So it should be done like that. Again, making sure it's going that way. Otherwise, you're just forming the image at some random point. So the actual image is formed here. Okay.